Let's look at some aspects of measures of relative standing. In this video, we're going to be looking at percentiles, quartiles, the 5-number summary, and my favorite box and whisker plots. So let's get started. Percentiles. Percentiles are a measure of location based on dividing up a set of data into 100 groups, 1% of the values in each group. P10, for example, denotes the 10th percentile, which has about 10% of all the data below it. P50 denotes the 50th percentile, which has about 50% of all the data below it. We've already looked at this. This is called the median. Okay, so let's say we have a selection of data here, age of randomly selected CEOs in Silicon Valley. And I want you to notice that they're arranged in order, which is very important when finding percentiles. So the youngest CEO in this data set is 20 years old, and then it increases up to 89. And there's 1, 2, 3, 4, 5, 6, 7, 8. Times 3 is 24, 25, 26, 27, 28 people here. So we're going to come back to that data set. I want to show you how to calculate a percentile. The formula we use is pretty easy to find a percentile of a data set. The percentile of a specific value, x, is equal to the number of values less than x divided by the total number of values in your data set, times 100, so we have a percent. So if k is our percentile, L is the number of values less than x, or its location, N is the total number of values times 100. Okay, so let's go back to that data set that we had before and say we want to find the percentile for the value of 41. So here's 41. There are 1, 2, 3, 4, 5 data points below 41. So our formula we're going to use is 5. So the number of data points less than 41 divided by 28. Remember, that was the total number in the data set times 100. So we find 41, count how many came before it, divide by the total number, and multiply by 100 to get our percent. We have 17.86%. Now, this is really important for percentiles. We always round up. Now, you'd probably be inclined to round up here because it's 17.86, and that would be correct. So we would say 41 is the 18th percentile. So I want to do another example where we have a slightly different decimal. So let's do another one. Same set of data. In this case, let's find the percentile of the value of 89. Oh, 89 is the largest one. Okay, so this would be, it has 27 positions before it, and there's 28 in the total, so 27 divided by 28, multiply by 100, 96.42. But we always in this case round up, so we would say this is the 97th percentile for 89. Okay, so no matter what decimal you get, you always take the percentile, the whole number percentile that is rounded up above 96.42. Okay, let's practice some where we go the other direction. So finding a data value when given a percentile, find the value of the 80th percentile, or P80. So the formula is exactly the same. The L and the K just switch position. L is equal to K divided by 100 times N. So N is the number of data values. The K was the percentile we're looking for, and L is the location of the value in the data set. So if we're looking at our ages again, to find the 20th percentile, or P20, we're going to do 20 is the K, the percentile, divided by 100, times the total number of data points. So 20 divided by 100 times 28 is 5.6. Now this number tells you the location. So we would do 1, 2, 3, 4, 5. Now we don't have a 5.6 spot, so we go to the next one beyond that. So this would be 41. Oh, we already knew that. In the last example, the 20th percentile was 41. So we go, this finds us the location, 1, 2, 3, 4, 5, and we go one beyond that. Let's try another one. Let's find P25, so the 25th percentile. So remember, the 25 is our K. So K divided by 100, or 25 divided by 100. N is the total number of data points. And 25 divided by 100 times 28 is 7. So something interesting happens when you actually get a whole number here. This is supposed to be the location of the numbers prior. So 1, 2, 3, 4, 5, 6, 7. In the previous examples, we had a decimal, so we went one beyond that. If our L is a whole integer, we find the mean of the values in that position L and the one after it, the L plus 1 position. Otherwise, just take L and round up if you have a decimal for L. So let's see, 1, 2, 3, 4, 5, 6, 7. So between 42 and 48, the mean of that, remember, add them together and divide by 2 to get the mean, would give us 45. So the 25th percentile is 45. That's the trickiest thing of finding percentiles, is when you get a whole number for your location. So find that position, the position beyond it, and find their mean. Okay, one final warning on this. Don't forget, when you're calculating percentiles, make sure your data is in order. It's really important when you're finding these. Okay, let's talk about quartiles. Quartiles are really just specific percentiles. We call them Q1, Q2, Q3, and they divide the set of data into 4 groups of 25% of values in each group. So if you're looking at a graphical representation of the data, the first quartile is the smallest, so the minimum, up to P25, up to the 25th percentile. And then quartile 2 is between P25 and P50. Quartile 3 is between the median, or P50 and P75. And then quartile 4 is everything above that. Okay, so in other words, what we just said, Q1 is the same thing as the 25th percentile. Q2 is the same as the 50th percentile, or the median. Q3 is the 75th percentile. And we're going to use the same formula as we did in the previous problems. So going back to our ages of the CEOs, if we're asked to find Q3, that's the same thing as the 75th percentile. So we do 75 divided by 100 times the number of data points, 28, and we get 21. But remember, since this is a whole number, we're going to find the 21st position, which is position in 70. So we're going to add 70 and 72 and find the mean. And we get 71. So the third quartile would be 71. Okay, when we put all these together, we can graph them on what we call box and whisker plots. And we have these 5 values that are represented in the box and whisker plots. The minimum value, the first quartile, the second quartile, or the median, or the mean, the third quartile, and then the maximum value. And these 5 numbers are also called the 5-number summary. So here's an example of a box and whisker plot where this down here at 20 is the minimum value. The beginning of the box is quartile 1. That looks like it's at 25. The line in the middle of the box represents the mean, or quartile 2. The end of the box on the right-hand side represents quartile 3, and the farthest whisker, if you will, on the right-hand side represents the maximum value. So minimum value, quartile 1, quartile 2, or the mean, quartile 3, and then the maximum value. And the idea is that most of our data should be fitting inside the box here. That's between quartile 1 and quartile 3. Okay, let's create a box and whisker plot for the following data. So here's all of our ages of our CEOs. So we're going to find the minimum value. Well, we already knew that. That was 20. The first quartile. So that would be the 25th percentile. I'll give you a minute to maybe pause the video and work that out. Find the 25th percentile. You should get 45. The second quartile, or the 50th percentile, if you calculate that, you should get 60. The third quartile we just did in the previous example was 71, and the maximum value we already can see is 89. So we're going to draw a number line and plot these numbers, 20, 45, 60, 71, and 89 on there. Where 20 is the whisker on the far left. 45 is the left side of our box for quartile 1. 60 for quartile 2, or the 50th percentile, or the mean, whatever you want to call it. 60 is the line in the middle of the box. 71 is the far right end of the box. That's quartile 3. And the end of the right-hand whisker is 89. Now, I want to make a comment about the mean. Depending on how big your box is, so where quartile 1 lies and where quartile 3 lies, your median, or quartile 2, doesn't have to be smack in the middle. And you can tell by looking, this number 60 seems a little bit on the right-hand side of this box, and that's totally okay. So your mean does not need to be smack in the middle of your box for your box and whisker plot.